Hello, this is Gabriel Barahona and I'm working with Curtis Jennings, and this is an update on our Engi 460 final project.
So we're going to be discussing the simulation and execution of our model and where we think we're going to be headed with how many different robots we're going to have and the various locations of spills that are around the manufacturing facility. Within our simulation, we want to have 20 robots that randomly move to each spill within the manufacturing facility. We want to have multiple spills and randomly located within the manufacturing facility. And when they start from the starting point, they randomly move towards them, find them, give a pheromone, and then come back to the original location. And for our code, we're just going to be discussing a few of the main elements within Eclipse. So as you can see here, this is the starting location, and these are coordinates, and this is the location of the food. We've declared that the number of robots is 20 and our evaporation constant is 0.999. And this switch statement shows the cases for if there's one obstacle or two obstacles, and it shows the location obstacles.field of each obstacle within the user interface. Moving into the ant tab, we can see that within this public void deposit pheromone, there is like nested if statements, and it basically shows that if an ant finds a food, it deposits the pheromone, and it's drawn back to its home location by a gradient vector to food grid.field.
For the ants foraging example there, the dynamics and the interaction between the different ants is due to the food and home pheromone, but in our specific project, in our specific application of spills in a manufacturing environment, this food pheromone and home pheromone code we see here would be similar, but instead of it being a pheromone, it'd be a sound system that once one of the ants finds an actual spill, it starts emitting this sound which the other ants sense through sound detection, and in a way follow the ant towards the shortest path to the specific spill. And this would be similar to the home and food pheromone. However, it would change in the sense that the evaporation constant would be slightly different because there's nothing being deposited. It'd be more of a sound. And some planning elements and things we hope to change in order to adapt to our specific simulation environment application is, first of all, we want to change the obstacles. Here there's a code for one obstacle, two obstacles, and as you guys see here, this obstacle field, if you change these numbers, the dimensions of the obstacles changes. So we are trying to make obstacles that fit more of a manufacturing environment, such as machines or squares that would stand for machines, and lines that would stand for production lines. And another thing, major important thing we're trying to change in this code is we are trying to have different food locations, and this is based on the food pheromone class and this algorithm, and we're trying to see if there's one home but there be multiple food locations which simulate the different spills in the facility.